Okay, let's look at the number 4. This line is tangent to the graph of y equals x minus x squared over 500 at the point Q. Be careful here. This equation is the red one, okay? And the blue line is tangent to this red curve, as shown in the figure below. The figure is not drawn to scale. They ask you to find out x coordinate of the Q. They're looking for here. This point, you have x and y. They want to find that one first. First thing first, you look at this blue line, okay? This line here. This line. We know we can write this one as what? Slope intercept form. So we have what? Y equals mx plus b. No problem? And we do not know the b yet. We do not know the slope. But we do know the y-intercept. Y-intercept equals what? 20 from here. X equals 0 here. That's y-intercept is 20. So you have the line right now, the blue line, tangent line equals y equals to mx plus 20. But after you got that, but you still do not know the m yet. But we can find this one by using derivative of this red curve function. So be careful here, this y means the line here, okay? I'm using the blue line here. I'm using this one here. I use the capital Y. Because y equals what? The x minus x squared over 500. So that means this one representing this red curve here right now. So if you do derivative of that, you will get what? 1 minus 2x over 500. Use the power rule, okay? And simplify, you will get a 1 minus x over 250. Now, this one representing what? The slope. Everywhere as long as the x changes. Maybe if x is here, the slope will be like this. That's from here. If x is here, the slope will be like this, right? So around like a 250 here, like this one here. If this is 250 here, 250 over 250 is 1 minus 1 is 0. So that's why here you have what? Horizontal tangent slope, right? Now, we know this one representing slope, but we don't know where's the x should be, right? But I'm going to apply this one to here, to this point here. So this y will be the point, y coordinate for this point on the line of the tangent and also on the line of the curve, on the graph of the curve. So this 2y must be the same, right? So if you have 2y the same, we can solve this in tangent point now. So the y here equals to mx plus 20. And from here will be from the curve, x minus x squared over 500. So they have same y coordinate because they touch each other. From there, we'll try to solve the x. But we still have the problem here, we don't know what's m yet. But m can be represented by this. So as I substitute the m to here, this value to here, okay? I have 1 minus x over 250 times by the x and the plus 20. equals x minus x squared over 500, right? And then this one times this one will be x. This one times this one will be x squared over 250, and the plus 20 equals x minus x squared over 500. Now, this one cancel each other, right? And then you can add by x squared over 250 on both sides, x squared over 250 on both sides. So you can cancel this too. So you have only 20 on this side equals to negative x squared over 500 plus x squared over 250. Now, before you do this addition here, what do you need to do? What? You got to change the same denominator, so you time by 2 here. Change to 500, so you time by 2 to the numerator. So I put a loop here, okay? So you will get what? 20 equals to 2x squared over 500, right? That's this part. And the minus this part, right? Because this is a positive, this is a negative, so you got a minus. So that would be x squared over 500. So you can have 20 equals to what? Same denominator right now. The numerator, subtract this numerator, just 1x squared over 500. Time both sides by 500. So you can get x squared equals to 10,000, right? And then x equals what? Square root. When you do square root, you're supposed to have positive and negative, but we know here the x is positive. So because x is positive, so we got square root of 10,000 will be 100. We got this now. We'll find the x coordinate of what? We'll find the x coordinate of the x coordinate of the cube, right? Recall what we did a little bit long here. We just say we have a straight line here, tangent line. This is the equation. And we know the b is 20 because there's a y-intercept here. And also, we know the curve functions this, red curve. Because these two graphs touch each other, they share the same y. So their y must be equal. So the y for the straight line is this. And the y coordinate for this red curve at this point will be this. They must be equal. And then we simplify this equation. Before we do that, we need to find out what's the slope. What's the slope here, right? How do you get a slope? From the derivative, we know the original function. If you do derivative, you got this one. This one will be the slope. I plug in this one back to here. We got this equation, right? So this is the line. This is the curve. Their y coordinate must be equal at the point Q. So make them equal. We got this kind of equation, and then solve it, simplify. We got x equals what? 100, okay? After you got that, this one will be easy now, because what? The right equation of the line. We already got the line here, but we just do not know what? What is the slope, right? The m, right? But right now, we can find the m now. You see here, we can have m equals what? 1 minus x. X, we find as 100 over the 500. 100 squared. Right? X is 100, right? Oh, wait a minute. The slope is 1 minus here, from here. I'm going to do this one now here. The slope, I put it here, okay? Easier. So slope equals what? The slope, yeah, we just simply put the closer, there's a better way. Yeah? So the slope equals what? 1 minus m, x. X is what? X equals to 100 here. So I put 100 over the 250. Okay? So we do this calculation. So we got 1 minus 100 divided by 250. We got 0.6. 0.6. Okay? So we find the slope equals 0.6 for the straight line. Now, if you find the equation of the line will be what slope, we just go here, right? But we do know the slope is what 0.6 now. So 0.6x and plus what? The b. What's the b? That's 20, huh? So we find the b. This is the answer here right now for this one, okay? Now, we go to the c now here. C is like this. The story, let me just erase this part a little bit first, okay? Now, they said, okay, just make it cleaner here. They said they will plant a tree on the top of the graph here, the curve here. This is a mountain, huh? So they said this tree will be how long? I don't know how up goes, but they told you that the tree must be 500 feet. And they said what? And this one represents the hill. There is what? A 50-foot tree growing vertically at the top of the hill. And does the spotlight of the at a point 0, 20, the spotlight from here, okay, directly along the straight line, the line showing shine, means you can spot on any part of the tree. So if this one 500 just this long, means what? No spot on the tree. If this tree is heat on this one or more, that will be what? You have a spot shine on that. So what we need to do is we need to find out, because we know this graph by symmetry, the middle point here is 250. So this coordinate here is what? 250, right? So that means here, this on the line, here the point is 250. But our job here is what? Need to find the y coordinate here and the y coordinate here on the line to see if they have any intersection there, okay? First thing first, we can find this, the line here, what's the y coordinate here, okay? Let's try to find this now. Let's find this now, okay? We got the equation there. Y equals what? 0.6x and the plus 20, right? And then x equals what? Equals 250 and add by 20. So let's calculate this one now here. We will get 0.6 times by 250 and add by 20. So we know this y coordinate here is 170 feet. So that means here must be just erase it easier. So we got this one here will be 170. Now, we need to find out what's this coordinate first, right? So then we can determine how high this one can go. This x coordinate is 250. This is the point on the red curve. Follow this function. So we can find the y from this function here will be what I'm going to use this now, okay? X coordinate is 250, so I substitute 250 here and 250 here. So I have what? 250 minus 250 squared over 500. So we do the calculation now. So 250 minus 250 squared divided by 500. So we got a what? 125. So we find out this one is 125 feet. So I can put it here, okay? Here. So here, this coordinate is 250 and 125. What's this y coordinate 125 means? Means from here to here, the height is 125 feet. And on the top of here, you add another 50 feet. It's not a 500 feet, that's 50 feet. Okay? So if you add 50 feet here, total height, the top of the tree here will be what? The height will be 120, this is 125, huh? So 125 plus 50 equals 175 feet. So the tip of the tree, the height is 175. And then the line through this one, hit on here, the height from here to here is what? 170. And from here all up to the top of the tree will be what? 175. So that means this light will spot on the tree 5 feet below the tip of the tree. So the answer for this one should be what? Yes. The line where the spotlight will be on the tree. Okay? So recall what we did on all those many steps. The basic things is that the first step is this one. You find the A first, x coordinate. That's because of what? The coordinates on this tangent point, the y coordinate on this straight line, and the y coordinate of the curve at this point must be equal. That's the basic thing. And then the derivative of the original function will be the slope of tangent line. That's what we got the what? The slope here. And then we plug it into here, got this equation. And then we solve it. That's the first thing. When we got the x coordinate, that will be easier. We can find the slope. We can easily determine the line. After we determine the line, we can find the 1x coordinate is 250. What's the y coordinate on the line? And also, we can use the curve function, find the top point of the hill. X equals 250 to find how high the most of the mountain the hill goes. And then on the top of that, we add 50 more because of the tree. That's 175. But here at 170, the height, so that means the lights can shoot on the tree. Okay, so this is a very interesting question. And if you have any question, please let me know. Thank you. Bye-bye.